Okay, so if we think back to the last video lesson, the one thing that all the equations that we solved had in common is that they were all written in factored form. Unfortunately, that will not always be the case. So what do? Fortunately, we're going to begin to learn techniques that will allow us to get polynomial expressions into factored form and then be able to solve those corresponding equations. Today, we'll focus on the most fundamental technique of factoring, which is factoring out a greatest common factor. So let's take a look back at the opener from the last video and see how this can help us kind of ease into this idea or into this topic. All right, so when we solve this equation oops, let's try that again. Grab the pen. When we solve the equation 2x plus 6 equals 0, in the last video, we subtracted 6 from both sides, then divided both sides by 2, and we got that x is equal to -3. So that's one way that we can approach that problem. There's an alternate approach that we could take that we probably wouldn't take for this particular problem, but we could do it if we wanted to. So if we look at the coefficient of x, it's 2, and the coefficient of 6, I'm sorry, the constant term is equal to 6. So 2 and 6 share a common factor. So what I'm going to do is I'm going to use the distributive property in the opposite way that we typically use it. And here's what I mean. So the common factor that's shared between 2 and 6 is 2. So I'm going to write that outside a set of parentheses. 2x divided by 2 is x. And then 6, positive 6 divided by 2 is positive 3. So we end up with this equation right here. And this looks a lot like the equations that we were working with in the last video where we had two factors that were multiplied together to equal to 0. So what I'm going to do is use that zero product property from last class, or last lesson I should say, and set each of the factors equal to 0. So 2 equals 0, and then x plus 3 equals 0. Well, clearly 2 does not equal 0, so we're not going to get a solution to this equation from that factor. But x plus 3, that could equal 0, so if we solve that equation, we get x equals -3, which is the exact same answer that we got when we solved by just subtracting 6 from both sides and then dividing both sides by 2. So we're going to kind of use not kind of, we're definitely going to use this sort of an approach right here, where we're taking out a common factor to help us solve equations moving forward. But before we actually start solving the equations, we're going to practice finding greatest common factors first. So I can let you read through this part that's right here, the factoring part. I'm having some difficulties here. The factoring part. I can have you read through that later, but what I'm actually going to do is just jump straight into the examples. So the examples were asked to factor out the greatest common monomial factor. So here's what we're going to do. I like to analyze both of the terms in the polynomial expression. I like to start off by looking at the numerical coefficients first. So in this case, 2 and 6. Do they share a common factor? And the answer to that question is yes, it's 2. And I'm just going to write that over here to the right of that expression. Then I start looking at each of the variable expressions. Do m squared and m share a common factor? They do. That factor is m. Now again, if I look at the two expressions, 2m squared and 6m times n, the first term does not contain any terms with the base n. So what we've done is we've factored out the greatest common factor, but now we need to find the factor that we need to multiply by 2m to get the original expression. So the way that I do this is I look at the first term and I say 2m squared divided by 2m. I can do that work over on the side. 2m squared divided by 2m. And that's just going to equal m. So in parentheses, we're going to write m. And then I'm going to do the same thing for the second term. 6mn divided by 2m is going to equal 6 divided by 2 is 3. M divided by m is 1. And we have an n left on the top, so it's going to be plus 3n. So now if we were to multiply this out using the distributive property, 2m times m is 2m squared. 2m times 3n is 6mn. So we have successfully factored out the greatest common monomial factor. Let's look at a second example. So we're looking to factor out the GCF, or the greatest common factor, of 20x squared y squared minus 4xy. So again, I'm going to focus first on the numerical coefficients. 20 and negative 4 share a common factor of 4. X squared and x share a common factor of x. Y squared and y share a factor of y. So now what we're going to do is divide each term in the expression by the common factor. So 20x squared y squared is equal to 20 divided by 4 is 5. X squared divided by x is x. Y squared divided by y is y. So 5xy. And then negative 4xy divided by the greatest common factor, 4xy, is just negative 1. So this is going to be minus 1. And then the last example of this type, 18s squared times t to the 5th minus 2s cubed t. So again, we're going to look at the numerical values. The greatest common factor of 18 and 2 is positive 2. S squared and s cubed is s squared. T to the 5th and t is just t. So again, I'm going to go over here, and 18s squared t to the 5th over 2s squared t. 18 divided by 2 is 9. S squared divided by s squared is 1. T to the 5th divided by t is t to the 4th. So in parentheses, we should have 9t to the 4th. And then negative 2s cubed t divided by 2s squared t. That looks like it's going to equal, well, negative 2 divided by 2 is negative 1. S cubed divided by s squared is s. T divided by t is 1, so it looks like it's just a minus s. All right, so I'm going to stop this video here. And then what we're going to do in the next video is we're going to see how we can take and apply this idea to solving equations. Hope this was helpful. We'll see you in the next video.